Hello, welcome. We are in Chapter 1, FST, and in this video we'll be going through Lesson 1.4. This is just going to be a part of this lesson because it is a little bit lengthy. So we're just going to kind of start at the beginning with talking about some quartiles and percentiles. The hope is that this is going to get us to creating a new type of graph, which we call a box plot. Now, on the second page of this lesson, we do see kind of a picture of a box plot. So this is kind of where we're heading. Now, there's going to be a couple key numbers here. One is the minimum, which we've already learned is the lowest number in a data set, and the maximum, which we've already learned is the highest number in a data set, and then the median, which is the middle number of a data set. A couple numbers that are going to be new are these quartiles. So we have something called this lower quartile and this upper quartile. So that's kind of where we're going to start, and we're going to talk a little bit about what a quartile is and how we calculate those. So the first quartile, or the lower quartile, we're going to abbreviate with a Q1. And this is going to be the median, which we know that median means middle, of the lower half of the data set. So what we're going to do is we're going to kind of cut this data set in half, and then we're going to find the middle of the lower half of the data set. The second, or the middle quartile, which we're going to abbreviate with a Q2, is going to actually just be the median of the whole data set. So we'll say that's the median, or again, we know that means middle of the data set. And that leaves the third quartile, or the upper quartile, which we're going to abbreviate Q3, and that's going to be the median, or the middle of the upper half of the data set. So this, to find these quartiles, we do need to be able to find medians. So that's kind of the key here. Now, before we actually jump into an example, I do want to kind of give a picture of what we're doing here, because these are called quartiles, but you might be like, there's only 3 of them. We only have a Q1 and a Q2 and a Q3. So how are they quarters? Well, if we think about this line as our data set, we're going to have the minimum down here. That's our lowest number. And we're going to have the maximum up here. And then we know directly in the middle is going to be the median, which we also just said was called Q2. Now, if we think about the lower half of our data set, this is kind of the lower half of our data set. If we cut that in half, so if we were to take half of the lower half, that's our first quartile, or our Q1. And then we also have this upper half, so above the median. And if we were to take half of that, we would call that our Q3. So what we actually see happening here is we're actually cutting our data into quarters. It's kind of easier to see with this number line here. We can see here kind of this portion from min to Q1, this portion from Q1 to Q2, this from Q2 to Q3, and this from Q3 to the max. So we kind of have those 4 quarters of our data. Each of those portions would represent 25% of our data, because we have each of those quarters there. So that's why these are called quartiles, even though there's 3 of them, Q1, Q2, Q3, they're kind of dividing our data into 4 quarters. Now, those 5 numbers, the minimum, Q1, the median, Q3, and the maximum, are actually what we're going to call our 5-number summary. So I'm going to go ahead and define this here. That will be the minimum, Q1, the median, Q3, and the maximum. So if you're ever asked to find the 5-number summary, those are the 5 numbers that we're looking for. All right, we're going to go ahead and find our quartiles for each of these data sets in example 1. So I'm going to find Q1, Q2, and Q3. Now, I like to start with Q2. I think the median is the easiest one to find. So if we look for the median, remember with the median, we can kind of cross off high, low, until we get to the middle. So if I cross off low, high, low, high, low, high, low, high, we get to the middle, and that median number is going to be 4 there. So my Q2 would be 4. Now, to find our other quartiles, I'm actually going to go ahead and erase that, so that way we can kind of see a little bit easier what these quartiles look like. Now, our median was 4, so that's kind of where we're splitting this data in half. So we see here that we have a lower half, and we have an upper half. Q1 is the median of the lower half. Now 4 is not a part of either of those halves because 4 was directly in the middle. So if we think about our lower half and we were to find the median, we could cross off high, low. We will have 2 numbers in the middle, but those 2 numbers are the same. So that means my Q1 would just be 1. And then if we cross off low, high for the upper, again, we end with 2 numbers in the middle. We talked about if they aren't the same, to find that middle value, we could add these and divide by 2. So if I do 5 plus 6, we get 11 divided by 2 would be 5.5. So that would be the number in the middle there. So we kind of cut it in half and then find the middle of the lower half and the middle of the upper half. We can do the same thing for data set B. So we're going to find all 3 quartiles, Q1, Q2, and Q3. I'll go ahead and start with my median. So I'm going to cross off low, high, low, high, low, high. We do end with 2 numbers in the middle there. So we end with 3 and 4. Again, if we wanted to find the median, we could add those and divide by 2. 3 plus 4 is 7. Divided by 2 would be 3.5. Now, because 3.5 isn't in the data set, that means where I'm cutting this data in half is in between those values. So 3 is actually a part of the lower half and 4 is actually a part of the upper half. And now if we were to kind of repeat that process for our lower half and our upper half, on my lower half, I have these 4 values, so we could cross off low, high. We do end with 2 numbers in the middle. So again, if I wanted to find the median, we could add those and divide by 2. That's going to give me 1.5. And the upper half, which 4 is a part of, we'll cross off low, high. We'll end with 5 and 7. And again, we could add those and divide by 2. 5 plus 2 is 12. Divided by 2 is 6. Now, one of the things we will be asked to find once we have our quartiles is something called the interquartile range. We've learned about range before. Range is a maximum minus a minimum. But here, if we're talking about the interquartile range, we're actually going to be finding the difference between our quartiles. Interquartile range is sometimes abbreviated IQR. So if you see that, that just stands for your interquartile range. And that's going to be our upper quartile, or Q3, minus our lower quartile, or Q1. So we could think of that as our upper quartile minus our lower quartile. All right, the last thing we're going to talk about kind of in this first part is something called a percentile. Now, there might have been times in your life where you've actually heard a percentile. For example, maybe when you were younger and you went to the doctor's office, they measured your height and they were like, oh, you're in the 90th percentile for your height. Or maybe you've gotten a test score back, like a standardized test score, like the M-STEP, and they're like, oh, you're in the 84th percentile for your score. What that means is that percent, so 90%, if your height is 90%, that means 90% of the people your age would be the same height or less than you. Or if you're in the 84th percentile on a test, that means 84% of the people who took the test scored the same as or lower than you. So it kind of gives an idea of where you fall in relation to the rest of the people in that group. So percentile we're going to define as it indicates that p%. So again, if it's the 90th percentile, that's 90% of the data values are at or below that data value. And we're going to use this equation to kind of help us find that. So to find the percentile, the 70th percentile or the 90th percentile, we're going to take the position number. This is not the number itself. This is kind of where it falls in the order of things, divided by the total number of objects or values. So if you flip, we're going to take a look at example 2, but really just parts B and C for this. We'll come back in the next lesson and do the rest of this. In example 2, the data set is math test scores for 35 students. So we have 35 students, these are the scores they got on their math test. We're asked to find the percentile rank for the score of 89. So here's our score of 89. To find our percentile rank, we are going to do the position divided by the number of values. Now, I know we have 35 students, so we know there's 35 test scores, so that means the number I'm dividing by is 35. Now, to find the position, we want to find where 89 falls in the order of test scores. And our scores should always be ordered in numerical order. So for example, if I start with the lowest score, that would be score 1. And then my next highest would be 2. And we could keep ordering our numbers until we get to 89. So I'm going to go ahead and order all of my numbers so we know where all of these numbers fall in relation to the other values. So 89 is in position 27. It falls at spot 27 when we order all of our numbers. So 27 should be the position number. And we can go ahead and divide. So I'll do 27 divided by 35. That's going to give me a decimal. Now, if we want a percent, we could turn that decimal into a percent. We do that by just moving 2 decimal places. So that would actually be the 77th percentile. That means 77% of the scores are at or below 89. Now, the other type of question we might be asked with a percentile is what test score is at a specific percentile. Now, this percentile is a percent. So if we kind of think about this as a decimal, the 20th percentile would actually be a 0.20 as a decimal. We know that the percent is equal to the position divided by the number of values, which in this case is 35. So I'm just setting my 20% equal to the position divided by 35. So if we wanted to figure out the position, we could simply multiply by 35 to cancel that out. If I do 35 times 0.2, we're going to get 7. That means 7 is the position of the test score. 7 is not the test score, but 7 is the position. So I could find the 7th test score, and the 7th test score would be 70. So 70 would be the score at the 20th percentile. So with percentiles, it is a little tricky. Make sure you're looking for the position number or you're finding the position number, but then you have to translate that to the score itself. If you want to finish the rest of this lesson, look out for the next video on lesson 1.4.